Today we start our last part in biology. It is about neurophysiology. And we start with chapter 9, function of neurons. You know that the last chapter in immunology was about the disorders of the immune system, and it was chapter 8. Now, chapter 9, it is the first chapter in neurophysiology, function of neurons. And document 1, the title of document 1, resting potential. Our objectives are an introduction. In this introduction, I will let you remember something about your prerequisites in neurophysiology. 1, understand the notions polarize the neuron resting potential. To discover the origin of the resting potential and understand how is resting potential maintained in a neuron. So let us start. And before starting, let me tell you something. We have 2 eyes. Yes, we have 2 eyes. All of us in this class, we have 2 eyes. Each one has 2 eyes. Very good. And what? This beautiful dog also, look to these 2 beautiful eyes. Also, the dog has 2 eyes. So we are similar to the dog. The dog has also 2 eyes. Another idea. Now, we have teeth. Show me your teeth, please. Good. Maintain them clean, huh? And what? Oof, look to these teeth. Okay, the bear also has what? Teeth. So we are similar to it. Okay, now a serious idea. We have also what? No. We have 2 ears. We have 2 ears, and look this beautiful donkey, and look to these 2 beautiful ears, long ears. Okay, so the donkey also has 2 ears. So normally, or what I want to tell you, and we are similar to animals. The animals have 2 eyes. The animal have teeth, and the animals have ears, etc., etc. But what? But we are the only animals that have a well-developed nervous system, making us the most intelligent animals on Earth. So for this, and I insist now, you should ask a question. Why we have to study nervous system? Ya Ustaz. Okay, wallah, why we have to study the nervous system? Because we are the only animals on the Earth that have this well-developed nervous system, and this makes us what? The most intelligent. We are dominating Earth by our nervous system. So for this reason, we have to study the nervous system. It is very important to ask ourselves, why should we study this subject or this topic, etc.? Yes, nervous system in reality is extremely important for us because it differentiates us from the other animals. So this nervous system, in order to be studied very well, we have to divide it into parts. Every time you divide something into parts, this will facilitate its study. The nervous system is made up or is divided into 2 main parts. The first, it is called central nervous system, CNS. We mean central nervous system. And the second part, it is what we name peripheral nervous system. So nervous system is made up of 2 parts. Like this, we will facilitate its study. Central nervous system and peripheral nervous system. The central nervous system in its turn is made up of two centers. Two centers. The first one, very good. It is the brain or encephalon. And what? What about the second center? Ahsant. It is the spinal cord. So, two centers, brain or encephalon and the spinal cord. While peripheral nervous system, it is made up of nerves. The first are the 12 pairs of cranial nerves that are related to the brain or encephalon, and 31 pairs of spinal nerves related to the spinal cord. So, as you see, each center is related to nerves. The brain is related to 12 pairs of cranial nerves, and the spinal cord is related to 31 pairs of spinal nerves. Now, in order to understand very well these two notions, central nervous system and peripheral nervous system, I will show you here central nervous system. Central nervous, CNS. Suppose the student asks me, Mister, do you want to go to swim today? Please pay attention for this. If someone asks me, Mister, do you want to go to swim today? What should I do the first? What I have to do first? There. No. I cannot give the answer directly. What should I have to do? What should I have to do in order to give a logical answer? Very good. I have first to what? To take information from outside. Is there a sunlight? Is it cold or hot? Do I have time? Etc. So I need to use my sense organs in order to receive information about the weather. So I will use my eyes as sense organ to see if it is day or night, for example. I will use my skin to take information about the external temperature. So first, there are receptors or sense organs that must take the information, and this information must be transported toward the central nervous system. So the information is transported toward the nervous system. Now what? In the central nervous system, the information, what? Inside the nervous system, the information, as I said, the informations in the brain, in the central nervous system, in the brain, mostly these informations are what? Are analyzed, are interpreted, and then we conclude. There is scientific reasoning. There is reasoning in the brain, in the central nervous system, and especially in the brain. So the brain, as central nervous system, will analyze, will interpret, and then will conclude something, and what will give an answer. The answers are given, and these answers are transported toward the mouth, the tongue, in order to express myself, in order to say my answer. The effector organ, example, the muscle. Sometimes I can do a movement in my hand, in my head, for example, or my hand, in order to tell you that yes, I accept, or no, I cannot go to swim. Or I can use my tongue and lips in order to tell you no or yes, I can go. So first, the receptors, the sense organs, take information. The informations are transported toward the brain. The brain will analyze, interpret, and give answers. The answers are transported toward the effector organ that will express my answer. Now, tell me, Which part of the nervous system is responsible for this transport of informations and answers? Very good. It is the peripheral nervous system. So, peripheral nervous system or the nerves are responsible to transport the informations from the receptor to the central nervous system and the answers from central nervous system to the effector. I hope you have the idea is now clear about central nervous system and peripheral nervous system. Good. Now look to this document. It shows us the encephalon in the skull. As you see, it's protected by the skull, the bone of the skull. This is the cerebrum and this is the cerebellum. What is important for me, this is the encephalon that is protected by the skull in the head. While the spinal cord, look to the spinal cord inside, and it is protected by the vertebral column. Okay. Now what? Now, in order to continue our study, it is important to, in reality, about the cells that constitute the nervous system. So, as I said, this nervous system, as all systems in the body, we saw, for example, for the immune system is made up of cells. The cells of the immune system as what? Who can tell me something about the cells? Very good. Mast cells, B lymphocytes, monocytes, etc., etc. And the immune system, the nervous system, is also made up of cells. It is the main cell of the nervous system. It is in reality called a neuron. So, as all systems of the body, nervous system is made up of cells. The most important is the neuron. The neuron is, we say, it is the anatomical and physiological unit of the nervous system. It is an anatomical unit, and it is the unit that constitutes. Physiological unit, the unit that gives the role, the functioning for the nervous system. There are also other cells, but the neuron is the most important. A neuron, look to this. This is a neuron. The neuron, in a simple way, it is made up of two parts. The first is called cell body. The cell body. Look to this in this document. Cell body is an important or the most important part of the cell. It must contain what? Very good. The nucleus. Look to this. So this is the cell body. It is this part of the neuron or of the cell, nervous cell, containing what? The nucleus. And around it, look to these ramifications or prolongations as the branches of a tree. And around there are what? The cytoplasmic prolongations. The cytoplasmic prolongations, look to these. They are numerous and short. Normally we name them dendrites. And one and long, we name it an axon in general. So, cytoplasmic prolongations are of two types. First, numerous and short, the dendrites. Look to these dendrites. Short and many, numerous. While one single and long, and it is the axon. Good. Now what? So, for example, it is an idea. It is a prerequisite. I am making a. I am letting you. I want you to remember what you know about nervous system. Your prerequisite about nervous system. It is an introduction at the end. Now look to this neuron. So as I said, this is the cell body here, containing the nucleus, and these cytoplasmic prolongations that are numerous and short dendrites, and long and unique, it is axon normally. It is the axon, yes. Now look to the axon itself. It is sometimes covered by a substance, white substance called myelin sheath. It is a myelin sheath here. And some other times also it is covered by this yellow part. We name it Schwannsal or Schwann sheath, the Schwannsal. I am saying sometimes. What does this mean? It means that maybe the axon also only is covered by myelin, and maybe it is only covered by Schwann sheath or Schwannsal, or sometimes both exist, and some other times none of these substances or sheaths does not exist. So what? I can consider here four possibilities, knowing that this axon is sometimes called nerve fiber also, and this axon or this nerve fiber is of four types, for example, because we have some axons or nerve fibers sheathless, without any sheath, without myelin yani, and without Schwann, or with only myelin sheath, or only with Schwann sheath, or both exist. For this, we say that this axon or nerve fiber can be one of these four types. I want you to remember that the nerve fiber may be an axon, and may be it is a dendrite. We'll see this later. So there are four types of axons or nerve fibers. There are four types of nerve fibers without any sheath, sheathless, yani no myelin and no Schwann, with only myelin sheath, or with Schwann sheath only, or with both myelin and Schwann sheath. We'll see what is the role of each, or what is the main role of myelin sheath especially. Good. So as we said, the neuron is the most important cell forming that constructs the nervous system. So look to the title of the chapter. I want to return to the title of the chapter. Look to this, please. Do you remember what is the title of the chapter? Function of neurons. A complete chapter, chapter 9, will speak about the neurons and the functioning of the neurons, because the neurons are the most important cells that constitute nervous system. So, if you want to study nervous system, you must study the neurons. Functioning of the neurons. So, many experiments were realized on the neurons in order to study their characteristics, or how do they work, etc., etc., etc. Many experiments, and I will tell you about two of them. Look to this neuron. This is the cell body. These are the dendrites, axon. Okay, now we are taking a part of the axon, and under a magnifying instrument, this is the thickness of the axon. They connected a voltmeter on the axon. A voltmeter is an apparatus that can measure the tension of the electric current. In reality, they connected a voltmeter in order to measure the tension of the electric current, and look to the two electrodes. Every electric device is what they have: two electrodes, two bonds or two electrodes. This is the first electrode, and this is the second electrode. They connected the electrodes on the axon. Does the needle indicate something? Look to the voltmeter. It has a needle. Okay, it has a needle that gave that will deviate in the case where there is the potential difference. Look to the needle. Once we connected the axon, the electrodes on the axon, it does not indicate anything. As you see, zero. Another experiment, it consists in inserting one of the electrodes inside the axon, and the second electrode remains on the surface of the axon. What do you remark here? Look to the needle. Does the needle indicate also zero? It indicates it deviated. What does the deviation indicate? Very good. There is a potential difference. There is an electric current. And look to this, a deviation. And the deviation of the needle in reality has two significance, two indications. The first one, it is that is an electric current. Heidi one. What about the direction of the deviation of the needle? Ahsant, bravo. The direction indicates the positive side and the negative side, or the positive pole and the negative pole. Look to this. It deviates, the needle deviates from the positive to the negative side or charge in the axon. Once the needle deviated in this direction, it means that this electrode that is on the axon is positively charged, while the second that is inserted inside is negatively charged. So we say that the axon or the neuron has two poles. It is what? Polarized. Very good. The neuron is polarized. It means that it has two poles as the battery, plus and minus. And this electric current that we are detecting in a neuron that is not functioning, it is at rest, it does not do anything. It is called a resting potential. Resting potential. What is a resting potential? It says it is an electric current, and look to the expression electric current. In reality, it is an ionic phenomenon. We'll see this later. It is an electric manifestation, if you want. Electric manifestation, because scientifically is not an electric current. We'll see this later, not now. Till now, I can say it is an electric current of low intensity detected in a neuron what? At rest. Resting potential. Look to the title of document 1. Please, I am sorry, but it is important to return to the title of document 1. Document 1, resting potential. The first objective was understand the notions polarized neuron and what? Resting potential. Why we say the neuron is polarized? Because it has two poles. How can we prove it? By using the voltmeter and connecting the electrodes, one on and one in. We will observe a deviation of the needle. This needle deviates from plus to minus, so there are two poles and the neuron is polarized. And this electric current that is detected in a neuron at rest is called resting potential. So the resting potential is an electric manifestation. Till now we say electric current of low intensity detected in a neuron at rest. Okay, next time I hope we'll continue. May God protect you and your family. Take care, and please keep at home. Do not go outside, and stay. يعطيكم ألف عافية.